What if you replaced windshield wipers with lasers? Imagine you're driving down the highway during a heavy rainstorm. Visibility is poor, your wipers are struggling to keep up, and you're thinking, there has to be a better way to do this. Then a spark of genius strikes. Lasers. After all, they're precise, powerful, and don't wear out like rubber wiper blades. Why not just vaporize the raindrops before they even touch your windshield? Let's say you go full mad scientist and mount a couple of laser emitters on either side of your car's hood. These high-powered beams would track the arc of your windshield and blast away water as it lands. No more squeaky wipers, no streaks, just pure, dry glass. At first, it sounds amazing. The future of windshield maintenance. But before we hand in our patents and start accepting innovation awards, we should probably check whether this idea makes even a shred of sense. First, what kind of laser would you even need to evaporate raindrops in midair? Ordinary laser pointers won't cut it. You'd need something with industrial power, the kind used for cutting steel or performing eye surgery on Terminators. Let's assume you're using a continuous wave infrared laser, like the kind used in material processing. These things can reach several kilowatts of power and burn through solid metal. Sounds perfect, right? Well, maybe a little too perfect. Imagine sitting in your car, aiming two weapons-grade lasers at your windshield, hoping they'll only hit the rain. If the alignment is off by even a millimeter, you're no longer drying the glass. You're drilling a hole in it, or worse, into something beyond it. And there's another problem. Physics. Raindrops are mostly water, which has a high specific heat and even higher heat of vaporization. To fully vaporize a single raindrop, let's say 1 millimeter in diameter, you'd need roughly 0.1 joules of energy. That doesn't sound like much, until you realize that thousands of these drops are hitting your windshield every second during a moderate rain. Multiply that by the number of droplets per minute, and suddenly your car needs to generate the energy output of a small power plant just to keep the windshield dry. But wait, maybe you don't need to vaporize the rain. Maybe you just need to disrupt the droplets enough so they slide off or scatter before sticking. That could reduce the energy needed and lower the danger level. Scientists have experimented with laser pulses to manipulate liquid surfaces before. Maybe you could use pulsed lasers to agitate the droplets and make them bounce off. But this leads us into another dilemma. What happens to the beam after it passes through the rain? Lasers don't magically stop when their job is done. If the beam continues beyond the glass, say, into traffic, you could accidentally blind a driver, fry a street sign, or start vaporizing someone's unfortunate garden gnome. Suddenly, your cool, futuristic invention becomes a public hazard. So maybe you decide to only operate the lasers while the car is parked, or when you're on a private racetrack where every car is also equipped with lasers and mutual destruction is just part of the thrill. That sounds reasonable in a video game. Now, let's consider thermal effects. Lasers generate heat, and if you're constantly zapping your windshield, you're not just drying it, you're heating it a lot. Glass isn't a great conductor of heat, so localized hotspots could lead to cracks or even shattering. On a cold day, you might end up replacing raindrops on glass with shards in your lap. But what about safety systems? Could you shield the lasers, add computer-controlled sensors to track rain patterns and limit power output? Sure, but now you've turned a simple $20 windshield wiper into a $5,000 precision optical system that requires military-grade targeting software and a warning label from NASA. At this point, you might be thinking, okay, so lasers are overkill, but surely they have some application in keeping windshields clear, right? Actually, yes. Some research has been done on using ultrafast laser pulses to modify the surface of glass itself. By changing the microscopic texture of the windshield, scientists have created superhydrophobic surfaces, ones that repel water so effectively that drops just roll right off. That's a far more elegant use of lasers, not blasting the water, but designing a windshield so water doesn't stick in the first place. In that sense, maybe your idea wasn't wrong, just aimed at the wrong target. The future of clear vision might not be melting raindrops in real time, but re-engineering glass so it never needs wiping to begin with. So, to answer the original question, what if you replaced windshield wipers with lasers? You'd probably blind a pedestrian, crack your windshield, melt your car battery, and end up in court. But hey, at least your car would look awesome doing it. Moral of the story? Sometimes, the most futuristic solution isn't about adding more firepower. It's about understanding the problem well enough to solve it with elegance, or just sticking with rubber wipers. They're cheap, effective, and unlike lasers, they don't come with a felony charge.
I don't think you'll be able to click on the next video before time run out. 3, 2, 1.